Welcome. Today we're going to do the leap year kata in Clojure. I'll be using the cursive plugin for IntelliJ IDEA. The leap year kata is quite simple. There's a bunch of rules. If it's divisible by 4, then it's a leap year. If it's divisible by 100, then it has to be divisible by 400 as well for it to be a leap year. If it's not divisible by 4, it's not leap year. So these are kind of 4 rules that we have. I'll be copying these rules and we'll get started. So let's create a new project. Call it leap year. We'll create a test directory. And under there, we'll create a test module. There's a leap year test. Okay, so let's paste the rules that I copied earlier and we'll create to-do lists from that. Okay. Starting our first test, dev test leap year tests. Testing. Let's start with our first rule. A year is not a leap year if not divisible by 4. Okay. So we will assume a function called leap year that takes a year. In this case, we will say, let's say 1995, which is not a leap year, and that should return false. Okay, before we run this, we have to configure a REPL. So Clojure REPL is a local REPL. We'll just call it REPL, and that's it. And we can get that running. I'll make this a little bigger. So there's our REPL running. I'll make this a little bigger so you can see what's going on. And let's run this test. Leap year not found. So we create the function. We'll create it in the same file for now, which you can create it in the production file if you want, but for the purposes of this, we'll just leave it in the same file. So that's a leap year function that takes a year. Oops. And returns nothing at the moment. If we do that, we get nil when we are expecting false. In Clojure, if you return nothing explicitly, it will return a nil. So in order to get that to pass, we return a false. And that's it. That's passing. Okay, so next one. A year is a leap year if divisible by 4. So that will drive out the next behavior for our function. So let's do that. Testing. Let's copy this rule. Okay. And we are saying is leap year. So in this case, let's say 1995, which we know to be a leap year, should be true. Okay. All right. We're expecting a true, but we're getting a false. So in order to make that work, we'll say the mod of year divided by 4 should be 0. Okay. Perfect. We got that working. So the next one is a year is a leap year if divisible by 400. Okay. So let's say 1600 should be a leap year. Copy that. Okay. What we are saying is leap year 1600 is true. 1600 is divisible by 400, so that should be true. Perfect. So the same implementation is making our test pass, but now comes the difficult part. A year is not a leap year if divisible by 100 but not by 400. Interesting. Okay. Let's create our next test. So what we are saying is leap year, let's say 1800, that is divisible by 100 but not divisible by 400, and that's, in that case, that should be false. It's not a leap year. Okay, finally our current implementation fails against that rule. So what we are saying now is if it's divisible by 100, then it must be divisible by 400, right? So what we are saying here is if $100, then must be divisible by 400. Otherwise it's divisible by 4. Okay, cool. So that's working as well. Let's try some boundary conditions. Is 0 a leap year? Right? 0 divided by 4 is 4, so it should be a leap year in our case. So let's add it to this, where we have the divided by 4 cases, and then say, well, 0 should be a leap year. Yeah. How about 3 should not be a leap year? About 1 should not be a leap year. That's fine. How about 4? That should be a leap year. 4, yes, that's a leap year. How about 2020? That should be a leap year. Yes, it is. Now we know that boundary conditions like adding a minus here would make this fail, and we can think about what kind of validation that this function should have and so on, but I think for the purposes of this kata we'll stop there. Okay, so let's remove the to-dos because we're done with the rules. But now we can start thinking about refactoring this. One thing we can see is that there is a lot of duplication in this 0 mod, and it's not very explanatory. What we can try to do is create a partial function from the year that will say divisible by, right? So the way to create a partial function in Clojure, you can say let divisible by, we're gonna make it a partial, and that takes an anonymous function that says 0, and it will take year, mod year, and it's expecting a parameter. So now we can remove all these, and this one will be divisible by 100. So we can say div by 100. We can see if that still works. Okay. Yeah, everything is still working fine. So now we can make these divisible by 400, and then divisible by 4. Nice. So now we can say that if divisible by 100, then must be divisible by 400. Otherwise, it needs to be divisible by 4. Oops. And that should work. Excellent. So that's one way of refactoring that. You can argue that the other one was better or not better, but it makes the rules a bit more explicit. So that's all. We have the leap year kata, and thank you for watching. Bye bye.